Welcome to video 4 of our 5-part video series on surds. And in this video we're going to talk about expanding binomials. So I'll just write that down up here. Expanding binomials is something that you've done algebraically already, so it shouldn't be a huge step up. It involves a distributive law. So let me remind you of a couple of things. First of all, a standard binomial expansion, a plus b squared. Well, that's equal to a plus b times by a plus b, which we distribute the first bracket over the second one. So we write that down as a plus b, a plus b, which gives us a squared plus ab plus ba plus b squared. And you'll notice here in these middle ones, we get that idea of commutativity again. AB and BA are the same, so I get A squared plus 2AB plus B squared. And so this is a standard expansion of just a squared term. And this will be an important shortcut for you a little bit later on. So you might want to recall it, remember it, or make sure that you can do it quite quickly. A minus B squared, for the same reason, is equal to A squared minus 2AB plus b squared. Go ahead and expand that yourself just to check that. And the last one is this, which is called the difference of 2 squared. A minus b times by a plus b is equal to, and I distribute again, so it's a times a plus b minus b times a plus b, which is equal to a squared plus ab minus ba minus b squared, and we have that and that cancel out, leaving us with a squared minus b squared. This is the difference of 2 squares. You can see a squared minus b squared, where minus is sometimes said the difference. So you can see where that comes from. I will make a quick note here, which I'm going to put in red because it's a really common misconception. A plus b squared does not equal a squared plus b squared. And you can see that now because we've got the expansion there. And so that's one common misconception. And here's another one for you. The square root of a squared plus b squared does not equal a plus b. And we don't quite have the example of that here, but obviously a plus b squared is here, which is that. And so the square root of that is equal to a plus b, not the square root of a squared plus b squared. It needs to have that 2ab as well. So just be very wary of those situations. So let's have a look at some examples of expanding surd binomials. First of all, the square root of 2 plus the square root of 6 squared. Now you could use that rule, that squaring of a standard binomial, in this case if you remember the rule, and that would be fine. But I'm going to do this the long way. So I'm going to start by writing this out as the square root of 2 plus the square root of 6. And I want you all to see that if you just do this the long way every time, it's the same procedure. And so they're quite easy questions. You should be able to get them all out. I distribute the first bracket over the second, which gives me the square root of 2 times by the square root of 2 plus the square root of 6 plus the square root of 6 times by the square root of 2 plus the square root of 6. And now I expand these singular brackets. The square root of 2 times the square root of 2 is the square root of 2 squared, and yes, I am going a long way. The square root of 2 times the square root of 6 is the square root of 12. Remember that multiplication of surds? The square root of 6 times the square root of 2 is the square root of 12, and the square root of 6 times the square root of 6 is the square root of 6 squared. And this, of course, is root 2 squared is just 2 plus 2 root 12, there's 2 of them there, plus 6, and so this is equal to 8 plus 2 root 12. And that's our simplified version. But of course, we have a root 12 there. Be very careful that we make sure we fully simplify. 8 plus 2 times root 4 times 3, which is 8 plus 2 times 2 root 3, which is 8 plus 4 root 3. That's quite a poorly written 4 there. There we go, 4 root 3. So I've done that simplifying. Every time I do a question in surds, I check to see if I can simplify the surd at the end, even if I haven't been asked. Just do it. So there's 8. I have two more examples for you. First of all, b, which is 2 root 3 minus root 6 times by 2 root 3 plus root 6. And you might recall this is a difference of two squares expansion. Again, I'll do it the long way, but you might want to go and just check using that difference of two squares rule here and see if it comes out the same. But I'll do it the long way. So first I will distribute the first bracket. 2 root 3 times by 2 root 3 plus root 6 minus root 6 times by 2 root 3 plus root 6. And this is equal to 2 root 3 times 2 root 3. I multiply the numbers to give me 4. And then I have root 3 times root 3, which is root 3 squared. Then 2 root 3 times root 6 gives me 2 root 18. Root 3 times root 6 is root 18. Minus root 6 times 2 root 3 is 2 root 18 again. And minus root 6 times root 6 is minus root 6 squared. Now I see here that these two terms are one's positive, one's negative, and they're the same, so they cancel out. I get 4 times 3, root 3 squared is 3, minus root 6 squared, which is 6. 4 times 3 is 12, minus 6, which is just equal to 6. And of course I don't have to worry about simplifying these surds because there are no surds to simplify. So believe it or not, this actually gives a rational answer. In fact, it gives us a natural number. So there we go. And example C. So we have root 7 plus 3 root 3 times by 2 root 7 minus root 3. And again, this one doesn't fit any of our rules because the two brackets are different. Only just, but they are different. So this time I'm going to have to distribute anyway. So I get root 7 times by 2 root 7 minus root 3, and then plus 3 root 3 times by 2 root 7 minus root 3. Now I expand. Root 7 times 2 root 7 is 2 times the square root of 7 squared. Root 7 times root 3 is root 21, and the negative sticks with that negative root 3. 3 root 3 times 2 root 7, the 3 times the 2 gives me 6. Root 3 times root 7 is root 21. And 3 root 3 times negative root 3 gives me negative 3 root 3 squared. Now, in the first term here, 2 times root 7 squared is just 2 times 7, which is 14, minus, now this root 21 is the same as this root 21 here, so I have negative root 21 plus 6 root 21, which gives me a total of 5 root 21. And then the last term is minus 3 times root 3 squared. Root 3 squared is 3, so it's minus 3 times 3, which is 9. And of course this gives me 5 minus 5 root 21. And there's my final answer. So there you have it, binomial expansion. You can set up a really neat procedure, distribute accurately, and you'll get the right answer every time, numerically or algebraically. But there are also some nice little neat tricks that you can learn and apply to save you a bit of time if you would like.